Hello, my name is Cole Watts, and today I'll be demonstrating how igneous rocks are formed. So first, igneous rocks are formed when burning hot molten rock crystallizes and solidifies. So the molten rock or magma is found deep within the Earth's surface, and it is always near either active plates or boundaries or near hotspots. And there's two types of ways that the igneous rock can form. It is either extrusive or intrusive. I made a diagram. So this is extrusive. It is when the magma chamber holds magma and then the magma goes above ground and then it crystallizes outside and solidifies outside of the crust so that it forms rocks on the outside like a mountain. But then if it's intrusive, it's going to stay inside of the mountain. So to have the same effect, the rocks will still solidify and crystallize, but it will stay inside the mountain instead of going outside. Now, some examples of extrusive rocks could be pumice, obsidian, or basalt. And then some examples of intrusive rocks could be diorite, granite, and pegmatite. And the only real differences between the two types is the growth size of each crystallization. So extrusive rocks crystallize faster because they're outside, so they will become smaller. But then intrusive rocks will always be bigger because they have more times to crystallize, so their crystals will become larger and it will be a larger and more solid rock. The other classification of igneous rocks is by their abundance of minerals, and it is split up into 4 different groups. There's the felsic, the mafic, the intermediate, and then the ultramafic. So felsic rocks are usually created through the same elements as feldspar and quartz rocks, the same elements that they're made out of. Then mafic rocks are created through pyroxene and biotite. Then intermediate rocks are like a combination between any materials in a mafic rock and any materials in a felsic rock. And then ultramafic rocks are dominated by like olivine and pyroxene, so they're more like a more condensed version of a mafic rock. Now, some other facts about igneous rocks is that they're very abundant. Roughly 90% of the Earth's crust is made out of Earth's rocks, igneous rocks, and 15% of all land on Earth is made up of igneous rocks.
Amethyst, also known as purple quartz, is the birthstone of February. The gem itself is not very rare, but there's a variation known as Deep Russian that can be worth as much as $40 a quart. This is very hard to find and is only found in parts of South America. Amethyst naturally forms in geodes and cavities of volcanic rock. After the beautiful gemstone is harvested, it is shaven down to its beautiful purple color. The gemstone was extremely rare until found in abundance in Brazil and Russia. Most of the amethyst today is found in Africa and South America. Amethyst was originally discovered in the 1600s by the Spanish conquistadors, but it was then rediscovered in the 1960s. The purple color is a good sign to many miners, as they believe good fortune and healing properties will be bestowed upon them.
Lithium. Good morning, science. Lithium, you're being that light. It's used everywhere. It's in batteries. It's used in medication. It's for the bipolar disease. Lithium was discovered in 1817 by a Swedish scientist. Lithium is a soft white silvery metal. It's used in medication and other substances like phones and batteries and all this type of stuff. Lithium, the mining process is very complex and crazy. When miners find lithium, they either go through a decomposition process or they attempt to mine it, which is very difficult.
Okay.
The atomic number 3 and the atomic mass is 6.9. It is known to be the lightest element and lightest solid metal. Lithium is also very important in science. It is important because it helps with heat transfers and alloys and neurotransmissions. It is found in most igneous rocks, but it does not occur in nature. Thank you for watching.
So for the effects that mining has on the environment, first there is pollution, where the atmosphere, surface waters, and groundwater can be heavily polluted. And this here is a stream that is clearly heavily polluted from mining. Another effect that mining has on the environment is destruction of land. This can happen through chemical contamination, destruction of productive layers in the soil, and also permanent scarring of the land, as seen in this picture. This can contribute to wildlife habitat loss as well. Another problem is the immense of energy it requires to mine, and this energy can impact already existing problems like global warming and acid rain. Mining also affects the biological environment, so it can directly impact plants or animals from just the activity of mining, and mining also exposes toxic soil and water to the wildlife, which can harm them badly. And see in this photo, this is fish in toxic water, and it got so bad that people are actually protesting against this. And since mining is constantly changing the surface water and groundwater, it can indirectly impact changes in nutrient cycle, species diversity, and ecosystem stability.